Hello, welcome back. This is Dr. Hussein, Renewable and Sustainable Energy, Module number 4, week number 13. This is the last session I will spend with you this semester. Hopefully, we deliver the required information or knowledge related to our course learning outcome. Now, I will talk about climate change and energy. Our discussion will be global warming and climate change, global energy profile, and climate treaties and policy. Now, let me start first with global warming, from where it came, what is the greenhouse gases, what is the greenhouse effect. Now, you know the temperature of the our planet is controlled within a specific level, okay? And this is related to the greenhouse gases. Greenhouse gases is some gases with a specific percentage for each one of them, representing the part of the atmosphere. You know that the temperature of the earth when it's received the solar energy coming from the sun, as you know, one third is lost in the space, and which is because we have 1360 watt per square meter. We lose the 360, and what is arriving to our atmosphere is 1000. This 1000, when it's excess, it's heat the warm, let me say, the planet, the earth, and the earth will emit infrared radiation. This infrared radiation will be captured by these gases in the atmosphere. So any change in these green gases, by the way, these green gases, we call them greenhouse gases, and their effect on the planet, on the heat on inside the planet, we call this greenhouse effect. Now these gases, okay, as you can see here, just to remind you, the solar energy, one second, okay, the solar energy coming from here, one third returning to the space, and what is returning, what's arrived to our planet here, absorbed by land and water, and then re-emitted in different way. You can enjoy this graph here to see the different way of emission from the land and the water. Now, these greenhouse gases, they classify them by based on under Kyoto Protocol. I will talk about Kyoto Protocol in this session. Into main gases represent the greenhouse gases in the atmosphere. These are carbon dioxide, methane, CH4, nitrous oxide, N2O, PFC, HFC, SF6, which is sulfur hexafluoride, and some other minor gases like ozone, CF3BR, CFC, sorry, and water vapor. Now, these gases have a specific percentage, and any change in their percentage would change on the atmosphere and would have more infrared radiation inside the planet, make it more warm, and this increase in temperature will is dangerous because it will make and create many problems on the as we're gonna discuss today. Now, this here is the graph in this figure. It shows these gases CO2 and N2O, CH4, and so on. But I would like to focus here and here and here. Only there are many information here, but just look as example CO2. CO2, its effect is global, everywhere. It's not locally or regionally, or it's global everywhere. It's let me say have impact, and its level of scientific understanding is high. We understand CO2, how it's created, how it's captured, utilized, storage, its effect, and so on. So this tells me that the main target here, when I compare CO2, N2O, CH4, and others, CO2 is the main target. So our focus will be on CO2 mainly. Okay. Now this CO2 is represent the main gas in the greenhouse gases, and it's emitted mainly today from our activities, humankind activities, from power production, from heat production, from transportation. Okay. Also, our let me say change we our fingerprint in on the land, we change it. We kill the green area. We make buildings, we make everything artificial, and we start emit a huge amount of carbon dioxide. Okay, it's coming from our transportation, our power plants, and our appliances, and so on. Now, according to the source of EU, European 27, this is a committee, let me say, of countries together, a group of countries together. The greenhouse emission mainly coming from transportation, industry, and power sector. As you can see here, here. Now, these represent around 70% of the emission. If we know, I will repeat this statement from time to time. If we know how to make development, how we can make improvement, we can reduce this emission. Okay. And this emission reflected on temperature increase. If you see this graph, well-known graph, from 1000 to 2000, okay, within 1000 years, the temperature fluctuate, yeah. But here you can see it's going up. Something wrong. The temperature start to be increased sharply because of our human activities. It start to increase sharply starting from 1980. Okay, you can see here this is more focus. You can see here the increase is sharp, and this temperature increase will make create a lot of problem on this planet. Now, these carbon dioxide, which affect the temperature, as I mentioned, coming from energy production and consumption. I will revise with you now this profile, the energy production and consumption. Now have a look. The global total primary energy supply, the supply, I'm talking here in megaton oil equivalent. Okay, here you can see from 1972 into 2005, all data, this is all data. Mainly, this is the blue one is from OECD. OECD is let me say, not the developed country, but industrial countries. As example, Europe, US, and so. These are the huge source of supply of energy. It's coming from them. Okay. Now, fuel use in this to produce this energy coming from coal, oil, gas, but as you can see here, mainly here the oil and the gas and the coal. Most of the energy sources consume these type of resources. Okay. As you can see here, coal 20%, oil 40%, gas 21%, almost 80%, more than 80%. And this is the comparison between the share for different region. As you can see here, between 1975 73 to 2008, still OECD is the highest, but it's reduced from 44. It's reduced to 44 from 60. Why? Because China, as you can see here, China. This part is China. Increase from 7 to 17%, which means there's a lot of done in China in terms of energy share. Now, electricity particularly, okay, also primary supply, okay, coming from thermal. I'm taking you step by step to a conclusion at the end, okay. This is as you can see here, the thermal plants, and the yellow here is the nuclear and hydro, okay. But let's focus on thermal. Thermal coming from what type of fuel they use in these thermal power plants to generate electricity. They use coal, they use oil, and they use gas. These are the main sources, which all of them represent fossil fuel. And even if the percentage change, as you can see here, 1973 and 2008, I'm comparing between them. As you can see here, still coal for generating electricity is the highest, okay, and oil and gas are taking the second shares, second and third places. Now, the electricity generated by region, if we look to the region where this electricity generated, mainly it's generated, as you can see here, in OECD. You see, these countries, industrial countries, the main places where we generate this electricity. This is terawatt hour. Okay. Now, as you can see here, OECD around 57% of the electricity generated in the world. By the way, there are millions of people, they don't have access to electricity. Now, renewable energy came to be part of this story. But before I go for renewable energy, I would like to say that the fossil fuel, if you look to oil, gas, coal, as you can see here, this is all data talking about 2004. The oil expectation to be here in the range of, let me say, 40 years. Within 40 years, the known and identified sources is into 40 years. There is expected reservoirs, okay, another 60 years maybe. But this is the most cost-effective oil. We go up here, it become more costly, okay, not attractive much similar to this one. The same thing for gas. What I want to say here, and coal, what I want to say here, these are depleted sources. It will end sometime in the near future. Now, renewable energy, we talk about water, biomass, wind, solar energy, geothermal energy, and if we increase their percentage, that would be great, and we will reduce the carbon dioxide emission, and we will keep the or fix the problem of temperature increase on our planet. Example from Europe, I will talk about Finland and their experiment here. You see, Finland, they cover their fourth of electricity supply from renewable energy. As you can see here, around 26% coming from renewable energy. Wind, biofuel, hydropower, okay? And also, you can see here that this renewable energy they use for generating electricity and for generating heat. They need wood-based fuel, which is biofuel or biomass from biomass, as we explained before, and wind energy, wind and hydro represent around 3.5%. Now, in countries in Europe, in 27 Europe countries, okay, group, you can see that their carbon dioxide emission is different from country to country. As example, some of them, like Germany, which is an industrial country, you see here it's have high carbon dioxide emission. Another countries, as example, Finland and Ireland, and so they have less carbon dioxide emission. This is depend on the sources of energy they use, the type of industry they deal with, and so on. Now, what we did. Now you may say, okay, how you be sure that it's our activity, humankind activity? Let me tell you what we did. Uh, I'm already from the slide. What was once prairie has now been divided into net blocks. We determine what grows in every one of those blocks. Pretty much also what grow outside of them. We have made artificial lakes, built huge cities, railway and roads. We have leveled mountains in mining and operations. Many of what major fissures are decline. We put the pressure on our resources on the planet. We change everything. I remember 20 years back when I came to Sohar, it's green everywhere. Today, all these green have been removed and we can see building, we see houses, and so more roads coming, more bridges. We don't say that this is wrong, no, but at the same time, it's affect our environment. It's affect the greenhouse carbon dioxide. I mean, it's good to have buildings, but it's good to have green area to recover our emission. It's good to have industrial area, but environment is an issue. We know, don't want to, let me say, to create more problem to the environment and create more CO2 from our, let me say, activities. Now, climate change prediction, the prediction of IPCC and IPCC, I will talk about it in the next few slides. Okay, they expected that there is positive global radiative forcing between zero point 0.6 to 2.4. The increase in solar radiation here because of its more trap of energy on this planet, and the temperature based on this increase around 0.74 Celsius. You may say it's less than 1 Celsius, yeah, but it make a huge difference. Increase in temperature in points will make difference on this planet. And just to give example about this 0.6 watt per square meter to 2.4, 1 watt per square meter forcing 60 watt light bulb. So if we multiply by the surface of the earth, which is given in kilometer, square kilometer here, we will find that it's equivalent to 8.5 billion light bulbs. Now, carbon dioxide density coming from power generation in Europe countries in 2003 is, you can see some countries because of the source of energy they use. Poland and Hungary, Romania have highest. Okay, some countries, as example, Finland, Norway, Sweden, they have less. And greenhouse gas emission coming from different sectors, transportation, industry, and power sector, as you can see here, these parts represent around 70%. Any improvement, as I mentioned, any development could make change, could make difference. Okay, these emission coming from different type of fuel, coal, oil, gas are the main. Okay, now if we evaluate from 1971 to 2005 the world CO2 emission by region, we will find again that the CO2 emission mainly coming from OECD. Okay, around 74% in 2005 is the share of world. Now, I've been mentioned that we need to make development, it will make difference, and this is one example. Okay, you see here, if we combine heat and power from the same application,